Hello guys, with the name of God Ram Ram. Congratulations to my student for recently cracking SD internship at Microsoft, Anukriti Raj. Also, one of my student has cracked full-time 51 LPA SD offer from Microsoft. In this meeting, we are going to solve a very difficult Microsoft OA problem, which was asked just few days back, okay, in October 2025. So, that problem is very difficult. The most important thing which you should know is that stop solving standard DSA questions and easy medium lead code GFG problems and standard DSA sheets like bubble sheet, driver sheet. Because when such Microsoft OA problem comes up for you, where is the link to that problem? This is a very hard unseen DSA question of dynamic programming. It requires multi-dimensional DP, lots of observation, and totally a different kind of thinking. If you're only doing standard DP questions, you can never solve it. Okay. So that's why I want you to do hard unseen DP questions and understand the essence of dynamic programming. If your dynamic programming, recursion, or things like that are weak, guys, I have the best free course for DP. Please trust me what I'm saying. Just do my DP course. It's free. Go and do it. Okay? Go and do it. Open this website, you find dynamic programming and complete it. It will change your life. If it does not change your life, let me know in the comment. So since years, students have been appreciating this DP videos. So guys, please go and watch them. Then there is the DP playlist of mine on YouTube as well. Please go through it. Please. Now, this problem is so difficult that you are not directly going to understand whatever I'm going to teach you. So the first part of this problem is revolving around the concepts and basics of knapsack dynamic programming, multi-dimensional dynamic programming, DPIJ and DPIJK. So all these things you can learn from this document, and I will attach the recording of the video. Watch all those things and then you come to this video. Basically मैं कहना क्या चाह रहा हूँ कि this question is so difficult that you need some prerequisite knowledge. The prerequisite knowledge is mentioned here. You will have to solve these basic questions first. Recording of this I have put in the description of the video. Watch it and then you watch the current video. Okay? Clear? You should be able to do this question on your own. Only then you will understand the Microsoft way. Which question? The question is given an array of size n. Can you find the number of ways to achieve a subset sum of j using the first I numbers, but you are only allowed to use k indices from the first 5 numbers. So if you can calculate that dynamic programming IJK, then you can come to the Microsoft online assessment problem which I'm teaching. If you are someone who is a beginner, intermediate, or somewhere between beginner, intermediate, or advanced person, you want personalized one-to-one mentoring with me. You want me to personally help you out with DSA, OACP, give you day life training depending on your level, beginner or intermediate or advanced. And you want top product-based companies, Apple, Google, Microsoft, Amazon, direct job referral supports and things like that. Indirect job referral support, whatever you want. Check this link out. Okay. The October cohort you can join it. The offer is still on that. Okay. And guys, when I do one-to-one mentoring, I put all my heart, blood and soul into it. I talk to each person for 1 hour, even more than that. You can check in my recent LinkedIn post. Okay, lots of work, like daily 12 hours I'm doing mentoring only. So while making video for you guys, my energy is little low, but no problem. So guys, the Microsoft online assessment problem is saying that you are given a two arrays A and B of length n. So you have to select exactly k indices from both of them, and the elements you select for particular index size should be selected in array A as well as array B. Okay sir, this is clear. Out of all the subsets of size k, select the best possible subset. What is the meaning of best possible subset? For each subset of size k, you will calculate the sum of elements from A and the sum of elements from B. And you will always take the smaller of them. And you will do this over all the subsets of size k. Try to make the smaller value as large as possible. Oh my god, such a difficult problem, man. So much you can try to think, but still you might not be able to solve it. But I will make it easy for you guys. I'm trying to record this video very fast because my YouTube audience is not watching my long form content where I explain in detail for 1 to 2 hours. If you're okay with my long form content, please let me know in the comments, and please like, share and subscribe. Okay, it helps me, it keeps my motivation high to keep on posting high quality OA videos for you, so your OA and CP skills can improve, so you can tackle any hard unseen DSA question in your OA as well as interview. Okay, so guys, two arrays are given to you. You have to consider all subsets of size k. Subsets means not subarrays. Just pick up any k elements from array A and array B. Always calculate G, which is minimum of the first sum from array A and the second sum from array B. Calculate this value G. You have to find the maximum possible G over all the subsets. So if I try to show you some particular example, guys, obviously to solve this problem, you only need very few things. Okay. Ram Ram. So you only need very few things. What are those things? The first thing, always start everything with the name of God, Ram Ram. Okay. So the first thing which you have to do, and the second thing which you have to do, listen. First thing is you will watch the video recording. Okay. From the description of the video, understand those concepts. Then you will come to this video. Or if you already know dynamic programming, you can directly watch this video. And you will just listen to me carefully. See, in every ingoing and outgoing breath, not take the name of God Ram Ram like this. This is the most important way for you to attain moksha, Amar Lok in this life. Okay. Now, going to the question, what I want to tell you is that let's say two array A and array B is given to you. So, array A is, it is given in the problem. It is given in the problem already that array A is 63651. 63651. 63651. Then it is 14592. 14592. 14592. So which k indices will you select? You can select any of the k indices. You consider all the subsets, but which one will you select specifically for this? You will select first, second, okay, 665. So let's assume one based indexing, okay, for just the ease. They are saying k is equal to 3. So which three indices you will select? You will select this guy, you will select this guy, and then you will select this guy. Why are these the best choices? Because when you select these guys, the sum for A becomes 6 plus 6 plus 5, and the sum for corresponding sum for B becomes 1 plus 5 plus 9. Okay. So 6 plus 6, 12, 12 plus 5, 17. And for B, the sum is 5 plus 1, 6, 9 plus 6, 15. I hope I am right. Yeah. So in 17 and 15, which is minimum? Minimum value is 15. So 15 is the answer. Now there are many other ways to do this, but you can never achieve a sum as big as 15. For example, you could have selected what? You could have selected 3, 6, 5. If you select 3, 6, 5 for A, you have to select 3 indices, right? Because K is 3. Then the corresponding elements in B will be what? 4, 5, 9. What will be the sum here? Sum here will be 6 plus 5, 11. 11 plus 3, 6 plus 5, 11. 11 plus 3, 14. And the corresponding sum here will be big, I think. 4 plus 5, 9, 9, 18. In 18 and 14, which is minimum? 14 is minimum. So if you select 365 or the index 234, the answer is coming as 14. But if you select index 134, the final answer is coming as 15. We want the largest answer. You might think to apply binary search. Some experienced veterans might think that, when we have to maximize the smallest value, we do binary search. We cannot do that here. You have to use your high level multi-dimensional dynamic programming. So let's directly jump to the solution to the problem. Now, why am I doing this? How am I doing this? Guys, you can only know that if you watch the recording. So please go and watch the recording in the description. Okay. If I add the recording also in this video, now this video will become 2-3 hours long and you guys don't have the patience to watch it. I know that. If you were my good student watching all of my videos, then I would not have such issues. But it is what it is. Ram Ram. Game is rigged. So guys, listen to me carefully. But I want you to work hard. If you guys work hard and watch my long form videos, I will shoot long form videos also for you. Now listen. DP, IE, J dpik difference we have to calculate. What does that mean? Guys, this is array A, right? This is array A, right? This is array B, right? Array A looks like this, right? Till A of n. And array B looks like this, right? Now the trick is that you will calculate array C such that array C you have to calculate such that C1 is nothing but A1 minus B1. You will calculate the difference between them. Okay. C2 is what? A2 minus B2. C3 is what? A3 minus B3. So dpik difference means if you consider the first I elements, if you consider the first I elements of the C array, you have to consider the first I elements of the C array. So if I is 3, you have to consider the first 3 elements of the C array. Why am I taking the difference of this? Because I'm considering the first I elements. Now, from the first I elements, I have to choose k elements. I have to choose how many elements? I have to choose k elements. After choosing k elements, can we achieve sum of A minus sum of B equal to difference? What does that mean? I will show it to you with a very small live example. If I take the array A like this, 1, 2, 3, array B like this, 0, 0, 1, okay? Now if someone asks you dp3 of 2 of 4, is this yes or no? This means what? That you are considering the first 3 elements of both the arrays. dp3 means considering first 3 elements of both the arrays. Then 2 means what? Then 2 means that you are only taking 2 indices from the first 3 elements. So if you consider first 3 elements from both the arrays, what will be the difference array coming out? 1 minus 0, 1, 2 minus 0, 2, 3 minus 1, 2. So if you consider the first 3 elements and only take 2 indices from there, can you achieve a sum of 4? Yes, you can select this and you can achieve 4. Answer will be yes. So if you select this guy and this guy, what is gonna happen? From the first 3 elements, you decided to select 2 elements, which are, let's say, the last 2 elements. So what will happen? 2 minus first sum will be what? 2 plus 3. Second sum will be what? 0 plus 1, right? So what will be the difference? 2 plus 3 minus 0 plus 1. This is same as 2 minus 0 plus 3 minus 1. So each index difference you can calculate and put in the C array, right? So what is 2 plus 3? 5. 5 minus 0 plus 1, 4. So 2 minus 0 plus 3 minus 1 is what? 4. So yes, you can achieve such a difference. That's it, guys. That's all you have to solve. So currently our dynamic programming is very intelligent. Our dynamic programming. Also, guys, in this question, you need to know the constraints are that n is from, you know what? N is from 1 to 100. Okay. The elements A of I, you know what? They are from 1 to 10. Okay. And the k value is also from 1 to 10. Okay. The k value is also from 1 to 10. So hopefully these things are clear to you people. Okay. So now just try to understand these things properly. So guys, it's clearly known to all of you what you are trying to do. Okay. You can try to internalize it in your mind. Okay. Listen. So I give you any array, you should be able to tell me that if you consider the first I elements of array A and B, can you pick up k elements such that sum of A minus sum of B is equal to this last number 4 or whatever difference we are trying to achieve? If yes, output yes or no. So what will be the formula for this thing? And the same thing I have written in the document also. You can see that dpik difference, is it possible to select a subset of size k from first I element such that difference sum a minus sum b? This is so complicated. This idea can only occur to you if you watch my video 1. These hard unseen DSA questions you have to do. Okay, first I element and many such questions are there in my dynamic programming course. My dynamic programming course is 150 hour to 200 hour long, and at least 25 to 50 hour DP courses on my YouTube channel also. Guys, go please watch it so then you can solve hard questions like this. So you pick up from, subset of size k. Okay, from the first I elements, can you pick up k elements such that The difference of sum A minus sum B is equal to difference. If possible, we output yes, else no. So what will be the recursive relation for that? Not recursive relation, what will be the basic formula? This is index I, right? So dp of I comma k comma difference. How will you know if it is yes or no? Pick not pick method, right? You can ask that is it possible that is it possible to use only first I minus 1 elements such that k elements are picked from those I minus 1 elements and the difference is generated. If this thing is yes, then this thing will also be yes. Simple ना. Let's say you refuse to use the index I कि भाई मैं तो index I नहीं use करूंगा. So if you are able to use 1 to I minus 1 and you are able to pick k elements from 1 to I minus 1 such that the difference is coming as diff. If this is yes, then this same will be yes for dpik also na, because if you are able to pick the k elements from 1 to I minus 1, those same elements if you pick up, you can say that you picked the k elements from 1 to I also, and the same difference was able to find, you were able to do. Second thing will be, you will be writing it as dp of I minus 1 k minus 1. So basically this time you will be only selecting k minus 1 elements from this part. You will only be selecting how many elements? K minus 1 elements. Because you are, this time you are going to select index I for sure. So A of I and B of I is going to get selected. So what will be added to the sum? Whatever is your sum now, difference. The difference of K minus 1 indices plus AI minus BI is going to get added. AI minus BI is going to get added. Okay. And this is the difference we wanted to achieve. Difference is difference of AI minus BI for the K minus 1 candidates which we selected plus AI minus BI. Because this time I am forcefully including this guy. So one candidate is getting included from here and K minus 1 is getting used from I minus 1. So from I minus 1, I need to select K minus 1 candidates such that their difference should be difference minus AI minus BI. Their difference should be what? Difference minus AI minus B of I. You will understand this thing very nicely if you watch the recording. So go and watch the recording. dp I minus 1, K minus 1 and this thing. If this thing is true, if this is achievable, then this is also achievable. So you just have to check, is this true? Then this true. But if this is not true, then check this. If this true, then this true. If both of them are failing, then only dpik you can say no. No means it is not possible to select k elements from the first I elements from array A and B such that sum A minus sum B comes as diff. Now guys, this was the basic version of dynamic programming. Now we will talk about the harder version of dynamic programming. This was the basic version of DP. Now the harder version which I want to talk to you about. Harder version of DP means this is damn hard. Even if you do entire DSA sheets, you'll never find question like that. So what are we supposed to do? Just chill, baby. Just chill. Okay. So what to do in the harder version of the dynamic programming? This time also dpijk will mean something. dpijk will mean, are you able to achieve the dpik diff, right? This time also your dp will mean something. Are you able to achieve this, yes or no? If you are able to achieve, store the maximum sum of b inside instead of yes or no. Earlier we were storing yes or no. This time if the answer is no, you will store minus infinity. If the answer is yes, you will store what? You will store for that particular subset for which the answer has come yes, what is the sum of b? And if there are multiple possible sums of b, multiple subsets satisfy the condition, store the subset which has the maximum sum of b. Why am I storing maximum sum of b? You will understand in some time. So guys, the formula will be very similar to what I discussed. DPI K difference. Is it possible to select subset size of K from first I element such that difference sum A minus sum A B is equal to difference? If possible, store some value which value will be explained further. The DP should store the maximum possible sum of B only. Okay. If it is possible, if it is possible using the, let's say the final values which we get is DP NK0, NK1, NK2, all of them mean what? Let's say you are able to calculate this. DP NK0, DP NK1. It means what? Till whatever is the maximum sum of difference you can get. This means what? This means you were able to select k indices as the question said from the array of size n such that sum of A minus sum of B is equal to 0. So you can say that A is greater than equal to B. This means dpnk1 means you were able to select k indices from the n indices of array A and B such that sum of A minus sum of B is equal to 1, which means what? Which means sum of A is greater than sum of B. So guys, all these dynamic programming states means that sum of A is greater than equal to sum of B. And in all of them, you have stored B, the sum of B. So sum of B is surely smaller than sum of A. So all these dynamic programming states will consider S of B as the minimum sum and S of A as the maximum sum. So all of them know the sum of B. All of them know sum of B because you are, if the answer is yes, you are storing sum of B and you are storing the maximum possible sum of B. And you know the nice thing? Even if you store the maximum possible sum of B, it will always be less than equal to sum of B because it is the rule of this dynamic programming to make sure that sum of A is greater than equal to sum of B because the differences are positive. So if you take maximum of all of this, you will get your answer. Now, one thing might be coming to your mind, sir. We have only considered those subsets where sum A was greater than equal to sum B. Then we did this thing, the analysis, and we understood some stuff. Okay. The detailed video version of this problem also I'm going to add in the description. Make sure you watch it, you will understand it. Okay. Ram Ram. DP NK0 NK1 तुमको क्या बता रहा है? ये तुमको ये बता रहा है कि अगर दोनों एरेज n साइज के कंसीडर किए जाए और उनमें से k एलिमेंट्स चूज किया जाए तो क्या ये पॉसिबल है कि सम ए माइनस सम बी 0 आ जाए? क्या ये पॉसिबल है कि सम ए माइनस सम बी 1 आ जाए, 2 आ जाए, पॉजिटिव नंबर आ जाए? तो सम ए माइनस सम बी जब भी एक पॉजिटिव नंबर होगा, इसका मतलब सम ए इज ग्रेटर देन इक्वल टू सम बी. इसका मतलब इन ऑल दीज सबसेट्स सम बी इज द स्मॉलर सम. दैट्स व्हाई व्हेनेवर आंसर इज यस यू आर स्टोरिंग सम ऑफ बी. अब जब सम बी स्टोर करोगे तो मल्टीपल ऑप्शंस हो सकते हैं. It can happen that two subsets are satisfying this condition. In that case, you will store the largest possible sum B. Largest possible sum B. And you can be rest assured that sum is greater than equal to that. I will try to do guys as much as I can do for you. Ram Ram. So in सबका max लोगे तो you will get the answer. But yes guys, we did not consider the condition when sum of A is less than sum of B. For that guys, it's a homework for you. You will create a reverse dynamic programming. What a problem, my god, what a problem. Reverse dynamic programming you will do. And this time you will store bi minus a of I. Okay. And again you will try to find the max of these things. Reverse dp nk0 nk1 and like this. The time complexity will be O of n into this k, right? K is 10. So 10 into the positive sums, right? Into 2000. And n was 100. So you can see 1, 2, 3, 4, 5, 6. 2 into 10 raised to 6 in general. Okay. And same goes for the space complexity. Okay. Takes similar space complexity. Okay. Now, guys, listen to me carefully. Okay. Ram Ram. So, guys, if you want to join the program, you can try to check this link out. I think we might not have seats available, but you can still contact the manager. So I wish lots of success for you. Make sure you become happy and successful in your life. Ram Ram.